Okay, we're going to move on to integration by parts. And this is where they get the formula from. We're going to take not the derivative of uv, but the differential of uv. Instead of writing du dx or dv dx, we just write du. We just write dv. The differential of uv. Well, remember, the derivative of uv, well, it's the derivative of the first times the second plus the first times the derivative of the second. d dx of uv. We just don't write dx. We just don't write dx. And I'm just going to recopy this. We get, and I'll say v first, v du. v du plus u du. Of course, it was a derivative of the second. Let's just try that again. The derivative of u times v is the derivative of the first times the second plus the first times the derivative of the second, which is dv dx. And for our differentials, we just cross out the dx. We multiply everything by dx. And though that's not exactly correct, algebraically it worked out perfectly. Plus u dv. u dv. Now we integrate both sides. We integrate both sides. Remember, if you have a sum, you take the integral of them separately. Okay? And then the next thing is the integral of a derivative. The integral of the derivative, say, of f prime of x, of f of x. Well, the derivative of f prime of x is, the derivative of f of x, is f prime of x. And the integral of that is our f of x. What do you take the derivative of to get f prime of x? F of x. And notice this cancels out. So we have the integral of d of some function. It equals to the function. That is, here's a function. We just get back uv. And this equals v du plus u dv. So let me write u and not v. u dv. Now, algebraically, we solve equation for this. That is, we bring that to the other side. That is uv minus the integral of vu. This is equal to the integral of u dv. That is your integration by parts formula. You better if I write the right side first. That is, I'm going to write this equals that. u dv is equal to uv minus the integral of v du. This is our integration by formula. And you can derive it if you forget it. If you didn't like the derivation, not a big deal. Here it is. There's the formula. That's the one you need to know. All I did was integrate the differential of uv. Okay, so let's put this on the top and then let's do some problems. Let's do some problems. That's the integration by parts formula. If I give you an integral, one moment please. If I give you an integral you call part of it u, and the rest of it dv. For example, if I give you x e to the 2x dx. Actually, let's just make it a little bit easier. Let's just make it e to the x. X times e to the x du. No u substitution is going to work. If I call that u, if I let u equal e to the x, then du would be e to the x dx, which I don't have. If I let u equal x, well then that's just changing the letters. Du will equal dx, and e to the u, well, I meant to say e to the x. That would be, well, instead of x, I can write u. So I'll get e to the u. I'll get u, e to the u, du. So that didn't help. Well, what else do we have? The answer is do it by parts. Not because x is first, but I'm going to call that u, and what's left over, dv. Okay, so I'm going to need u, I'm going to need du, I'm going to need dv, and I'm going to need v. I need 4 of them. I definitely need u and v. And I already said I need v. I need du. Well, on the right-hand side, I don't need du. I meant to say dv. But on the left-hand side, I need dv to get v. The left-hand side, I need dv. I need everything I wrote down. U is x. So then du will be dx. dv is e to the x dx. dv is e to the x dx. And if I were to integrate both sides, the integral of the left side is v. The integral of the right side is e to the x. Don't worry about the plus e. So now I have everything I need. So first I write down u, which is x. And then I write down v, which is e to the x. Then I write down a minus sign. Then I write down an integral sign. Then I write down v, which is e to the x. And then I write down du is dx. Now, if you made the right substitution, if you made the correct u substitution, you should now know this integral. And just so it looks better, the x is in the power. So the n plus c. So the x e to the x minus the integral of e to the x dx is just e to the x. So there's the answer. Factor out the e to the x, fine. X left over here minus e to the x times 1 plus c. Take the derivative of this and you x e. I know it's correct. I didn't make a mistake. That answer will give you x. In a little while, a way of doing that problem. Suppose we have the integral of x cubed times ln of x dx. Remember, the integral of u dv is equal to uv minus integral of v dv. So, call part of my integral on the left u and the rest dv. I'm going to call that u and that dv. U is equal to x cubed So then du will be 3x squared dx. And dv, okay, well dv is ln of x dx. The thing is I don't know v. I don't know the integral of ln of x. You know, the derivative of ln of x, I don't know the integral of ln of x. Well, that just means I'm going to switch things around. I'm going to switch what I called u and dv. I'm going to let this be u and everything else dv. I'm going to let u equal ln of x. So du is 1 over x dx, which is dx over x. dv, I'm going to let that equal x cubed dx. So v, which is the integral of this, will be x to the 4 over 4. Okay? So this is equal to u times v, u times v, x to the 4 times ln of x over 4. If I would have written ln of x times x to the 4, one might assume we're taking ln of that. Minus the integral of v du. du is 1 over x dx. But this integral, we can do that one. We can do new integral. Copy down the front part, minus, well, the 1 over 4 I'll bring in front of the integral, and x to the 4 for x is x cubed times dx. That's the u to the n du integral. There's the 1/4. The integral of x cubed, x to the 4 over 4 plus c. Now factor out x to the 4 over 4. We can do that. X to the 4. So we have ln of x minus 1/4 c. ln of x minus 1/4 plus c. If we backed it out, circle. So what goes inside these is what I did encircle. The L is the 1, the division line, and the 4. Let's do some more. Suppose you have ln of x over x dx. Okay. Now, the question is, do you need to do this by parts or not? If I call this u, well then that's du. Dx over x. Well, that would be what's left over. If u is ln of x, well then du is 1 over x dx. That is, oh yeah, it is what we have, dx over x. So that's u, integral of u, times du over, times dx over x, which is du. That's a simple integral. u squared over 2 plus c. It's u squared over 2 plus c. And u, I'm not going to guess, so try to remember. I'm just going to look and read it off. There's your answer. Now, the question is, could you have done this using parts? After all, this is the section on integration by parts. So we're going to redo this integral, and we're going to see if we can do it by parts. You have the integral of times dx over x. And remember, the integral of uv is integral of u dv is uv minus integral of v du. So I call something u. Now remember, you're going to call something u, and whatever u is, you can find the differential. But now, you're going to call something else dv. You can't integrate everything. So what you call dv, you want to know how to integrate. If I call ln x dx, if I call that dv, I'm in trouble, because I don't know the integral of ln of x. So we have ln of x times dx over x integral. Well, that's the same as ln of x times dx over x, the integral. Maybe I know the integral of dx over x, so that's what I'm going to call dv. And u is going to be ln of x. If u is ln of x, du is 1 over x times dx. That is dx over x. And if dv is dx over x, if I integrate both sides, the integral of dv is v, and the integral of dx over x, well, that's ln of x. That's the value of x. So now I have u, v, du, and dv. So this integral on top is equal to u times ln of x times ln of absolute value of x. So now, it's already that x is not negative. You can't take ln of a negative value. So the second thing, we know that ln of x is positive. It has to be. It can't be 0. ln of 0 is not defined either. X times ln of x, which is ln of x squared. That's u times minus integral of ln of x times du. But du is dx over. Okay, so let me get rid of this stuff over here. And let us do that last integral. So we have ln of x squared minus, if I call that u, if u equals ln of x, then d will be 1 over x dx, which is dx over x. You have u du. Okay, so that's going to give you u squared over 2. U squared over 2. Well, we have one of these, and now we are taking away half of them. We have 1 ln of x squared, and we're taking away half of ln of x squared. And you can factor out ln of x squared. We have 1 minus a half. We have half of it. Minus a half is half. This times that is the same as that times this. That is, I'll say this a half first, which is a half. Half of ln of x squared plus c. plus c. And this is the same answer we got a moment ago without doing integration by parts. You didn't need to do this problem by parts. In fact, the top is u, and what's left over, which was dx over x. You let ln x be u, and what was left over, namely dx over x, that was du. Okay, let's try another one. Let us try to do the integral of x times cosine of x dx. Let's call it I for integral. Well, if I let u equal, I let u equal x, fine. Then du will equal to dx, and if this is u, then what's left over is dv. dv is cosine x dx. So v would be sine x. Okay, so this is equal to u times v, x sine x, minus integral of v, uv minus v du, sine x cosine x. This is x sine x minus, the integral of this is minus cosine x plus c. So you get x sine x plus cosine x. And there's your answer, except I should have written plus c. Let's check it. Let's take the derivative and see if we get x cosine x. It's the derivative of this plus the derivative of that. The first term, is the product. We use the product rule. It's the derivative of x times sine x plus x times the derivative of sine x, which is cosine x, plus the derivative of cosine x, which is minus sine x. That here is sine x, and when you take away sine x, you get nothing, and you get x cosine x. I did make one mistake. I shouldn't put the equal sign here. This does not equal its own derivative. Well, I call it in, okay, it does not equal its own derivative. So let me get rid of that. And I took the derivative of my answer. Oh, I'm sorry. That equal sign was correct. I just cleaned up the line above by dealing with those two negative signs. The derivative of this box, the equation right here, is this, which equals x cosine x. Exactly what we wanted. Let's try this one. Suppose you were asked to find the integral of sine x, I'd rather do cosine x. Cosine x times e to the x. Cosine x times e to the x times dx. Well, I'll let u be cosine x. So then du will be negative sine x dx. And if this is u, then that's dv. So dv is e to the x dx. Integrating both sides, I get v on one side and e to the x on the other side. Okay, so this integral on top is u times v. It's u times v, that is cosine x times e to the x, minus integral of v du. v du. No, that's not du. That's not du. v du. It's e to the x times negative sine x dx. So the negative will make that negative a positive. Well, we're kind of in the same ball game. I had e to the x dx times cosine x, the integral of that. Now I have e to the dx times sine x. Didn't seem to really get anywhere. So sometimes you have to integrate by parts more than once. Let's integrate by parts again. Since I let u be the trig function, I'm going to do that again. I'm going to call that u. Let u equal the trig function. So then du will be cosine x dx. And dv is what's left over, namely e to the x dx. And the integral of that will be v equals e to the x. Okay. So plus the integral of that. The integral of that is uv e to the x sine x minus the integral of v du cosine x dx. Now, if I call this integral I, so I have I is equal to this. I is equal cosine x times e to the x plus e to the x sine x minus, it says this is I. So I'm going to bring I other side. So now I have 2i is cosine x times e plus e to x sine x. Of course, there should be a, and now I divide by 2. There's your answer. Another way of writing I kind of sum in the bottom right corner. Another way of writing I, just look at the definition. Way of writing I is cosine times e. And now I know what it equals. It equals this. The x times cosine x for 2 plus your constant. So sometimes when you integrate, sometimes you need to integrate by parts more than once. Other times, when you integrate more than once, you get back where you started from. You started off asking what that integral was, and in your answer, you have that integral again. Fortunately, it was minus. That is, when I bring it to the other side, I didn't get 0. Okay, so there's a case where you integrate by parts twice, you get the same answer even. Or part of your answer equals the other side. You get the same integral on both sides, and you then solve for that integral. Okay. So now, I talked about, so let's look at this problem. Suppose you had x squared sine x dx. Let's try to do this by parts. I'm going to call that u, and I'm going to call that du. I want to try, notice that when you, well, you'll see that in the integral, let's see, the integral of uv is, the integral of u dv is uv minus the integral of v du. That new integral that you have to solve has a du. Well, if you were to let u equal x squared, well then du is going to have a lower power of the x. It used to be 2, now it's 1. And that's good. See, if the x squared wasn't there, we can integrate this problem. It's the x squared that keeps giving us a hard time. If u is x squared, then du is what's left over. Sine x dx. And then integrating gives us negative cosine x. So let's see what I'm talking about. You get uv. You couldn't care less what u and v were, because when you multiply them, you get what you get. You don't have to integrate. Minus the integral of v, which has its own minus sign. That's going to make it plus in front. Cosine x times du. But du is 2x dx. The 2, like I always said, I like to put in front. This integral is similar to the last one. Instead of sine, we have cosine. But the big difference is now we just have x to the 1. The power of x dropped. So this is equal to negative x squared times cosine x plus 2 times whatever this integral turns out to be. Do it all over again by parts. I'm going to call that u. Let u equal x. So du equals dx. Integration by parts is the only time you would call something u. Excuse me, you would call x u. Or you will let u be y or z. Why? Because you also have dv, which is not so simple looking. It's just cosine x dx. And v is not simple. You're just not integrating dx. You get some. So you're going to get u times v. You're going to get x sine x minus the integral of v is sine x, du is dx. But we know this answer. The answer is negative cosine x. Okay. Now, in other integrations where when we made a u section, we said this is u. Then at the substitute back. You look at the thing I wrote in terms of solving this integral. I never wrote anything but x's. Okay, so now you get squared times cosine x plus 2x sine x minus and minus, that's really plus cosine. So you get plus 2 times cosine x plus c. There. Okay, very hard looking problem. But there's an easier way of doing it, called the tic-tac-toe method. You want to know what the integral of x squared times sine of x is, dx. You want to make two columns. One where you take derivatives, and the other side where you integrate. So, you're going to take the derivative of that and the integral of this, or vice versa. You're going to keep taking the derivative of this, or and integrate that. But you want the derivative eventually to go to 0. Ignoring their plus and minus signs. When you have sine x, you take the derivative, you get cosine x. You take the derivative, you get sine x. The derivative, you get cosine x. Fine, I agree there's a minus there. Forget the signs. Okay, minus, plus sine x. You're not going to get 0. So it's not this piece that I'm going to take the derivative of, but rather that piece. Because if I keep taking the derivative of x squared, which is 2x, and then 2, and then I get 0. In the next column on the integral, I put sine x. And I integrate it. The integral of sine x is negative cosine x. And the integral of negative cosine x is negative sine x. And the integral of negative sine x is cosine x. And I stop. That's where I stop. Okay? Now, the answer is going to be positive this product minus this product plus that product, and that's it. That is, this integral x squared sine x dx is equal to this product, which happens to be negative, minus this product. That product is negative, but when you subtract it, it becomes plus 2x sine x plus that product plus 2 cosine x plus c. There's the answer. There's the answer right through this problem. Let's try another one. Use the definition of what? Of integration by parts. If you have the integral of x cubed e to the x dx. Well, I'm not going to ever take the derivative of e to the x enough times and get 0. The derivative of e to the x will always be e to the x. And then take the derivative of x cubed. That eventually will become 0. X cubed, 3x squared, 6x, 6, 0. Eventually, I get to 0. The other side, I integrate e to the x. So that's an easy one. The integral of e to the x is always e to the x. In fact, every time you do the product, this product minus this product plus that product minus this product, plus, minus, plus, minus. You're always going to have e to the x as one of the factors. You can even factor it out. You're going to get this product, x cubed, minus this product. Well, I factored out the e to the x, plus this product. Well, I factored out e to the x, minus this product. And there's the plus c. And there's the answer. Otherwise, you'd have to do integration by parts 3 times. The first time you do, you're going to get some stuff plus some number times x squared e to the x. And you integrate again, and you're going to get something plus the integral of x e to the x dx. That's 1 times, and then you integrate by parts again, and this will become e to the x, which we know. You'd have to do integration by parts 3 times. The shortcut method, that is this method, much, much quicker. Much quicker. When can you use this method? When u or v. Remember, you integrate one thing times another times dx. You're integrating one thing times another times dx. If i's are one of these, if you can differentiate it enough times to get 0, say this one, you differentiate it enough times to get 0, and you know the integral of this, that same number of times that you took the derivative of the first, then you can play this game. In other words, if you had x squared ln of x dx, you may say, oh, I know how to do this one. This is the one where you use the tic-tac-toe method. And you attempt to do it. You can take the derivative of x squared, and then the derivative, which is 2x. and then the derivative of 2x, which is 2, and then derivative of 2, which is 0. Looks like it's working fine. Now you're going to integrate ln of x. ln of x, I don't know the integral of ln of x. So this method did not work. Okay, what you might, well, maybe it still will. Maybe I'll differentiate that. So you have ln of x. The derivative of that is 1 over x, which is x to the negative 1. The derivative of that is negative x to the negative 2. The derivative of that is positive x. The derivative of that is going to be positive 2x to the negative 3. But it's not, you're never going to get to 0. This is not working. This is not working. You'd have to integrate this by parts using the regular technique. It doesn't work with the shortcut method. Earlier, it was a pain in the neck to do a problem like this. Possibly we did it with cosine x. We had to do it by twice. We got back the same result. We got this back again on the other side. This too will not work with the spaghetti method or the tic-tac-toe method. If you keep differentiating x, you're never going to get anything but e to the x. If you differentiate sine x, it's really not going to help either, because it keeps fluctuating plus minus sine x and plus minus sine x. It's not going to 0. So this is a problem to use the standard technique of integration by parts. But if you can take the derivative of those two factors enough times to get to 0 and integrate the other side as many times as you had to differentiate the first part, I would use the shortcut method. Somebody asked me what the integral of x to the 6 times e to the x is. I can actually write that down. It's going to be x to the 6 minus the derivative of x to the 6 plus the derivative of 6x to the 5th minus the derivative of that plus the derivative of this minus the derivative of that plus 720 plus c. You want to see this more formally? Derivative of x to the 6 is 6x to the 5th. The derivative of that is 30x to the 4th. The derivative of that is 120x cubed. Then 360x squared. And then 720x. And then 720. That's that. This we integrate, which is always e to the x. Which is always e to the x. So always e to the x. And then it's positive this product minus this product plus that product, etc. But clearly, they're all going to have e to the x. So I get plus x to the 6th minus x to the 5th plus 30x to the 4th minus 120x cubed. I get this like this. Don't forget to say plus c. It eats through these problems. This one, you have to integrate by parts 6 times. You'll be losing your mind by the time before you get to the end. Or you can say, you know what, this is pretty easy. I like these. Okay, good luck with integration by parts.